So hopefully putting this together now, we can see that a buffer solution consists of a weak acid and its conjugate base. And those weak acid and conjugate base concentrations should be in appreciable amounts, and we want them to be approximately equal. And we'll see later that we can adjust that ratio between the concentrations of the acid and its conjugate base to adjust the pH of our buffer solution. But we'll also see that buffers work best when those concentrations are relatively equal to each other. Okay, so if we take a look at the Ka expression from the equilibrium above, and we rearrange this Ka expression for the hydronium ion concentration, we should get something that looks like this. The hydronium ion concentration should be equal to the Ka multiplied by the acetic acid concentration divided by the acetate ion concentration. And the reason we want to do this is because when we're dealing with buffers, we're often interested in the pH. And so that means knowing what the hydronium ion concentration is. And so from this, we can see that the hydronium ion concentration, and therefore the pH of a buffer solution, is dependent on, first of all, the Ka of the weak acid, and two, that ratio between the weak acid and the conjugate base concentration. In the next video, we're going to do some calculations to see how adding acid or base to this equilibrium system will affect its pH.